All right, good afternoon. I want to review naming angles with us from 1.5 day 1. So there are 4 different names we could give this angle. Remember, we could name it by the vertex, the number, or the 3 letters. So I could call this angle K. I could start with the vertex, that pivot point. I could also name it by the number. So this could be angle 1 if I want to. And then the last 2 names I could give this are going to be the 3 letters here. So I can name it JKL. Name this angle JKL, or I could name this angle going the opposite direction, LKJ. As long as the K, that vertex, is in the middle, that's all that counts. And then, of course, we can classify this as well as either acute, obtuse, or a straight angle. So, seeing that this is bigger than a 90-degree angle, so bigger than a right angle, but not quite a straight line, that's going to be an obtuse angle. And here's a different problem. This was one of the problems on your homework. I just changed the letters around and changed some of the positions of the angles. But let's look at, again, how to measure angles. So it doesn't matter which numbers you pick. You can pick the top numbers or the bottom numbers. So this is either 35. You can see here halfway between 30 and 40 is 35. Or halfway between 140 and 150 is 145. So it's either 145 or it's 35. And this angle up here is going to be 90 either way. So just like I said with our distance formula, you don't need to worry about which one was x1, y1 and which one was x2, y2, as long as you were consistent. Same idea here. So you don't need to worry about which set of numbers you pick as long as you are consistent. So if I start with the top set of numbers, that 90, if I start with the top set of numbers here, well, then I've got to make sure I use the top set of numbers on the other part of my angle as well. So here we're going to look for the difference of 145 and 90. So if I go from 90, I can go 10, 20, 30, 40, 50, 5. Or if we want to use the blue numbers, I can go from 35, let's go 5 over to 40. So 15, 25, 35, 45, and 55. So if I did 90 rather, if I did 90 minus 35, I'll still get 55. Because I was consistent, I picked the top row of numbers. So if I started with the top row, I subtracted the top row over here. Or if I started with the bottom row, that pink highlighted set of numbers, then I subtracted it from the bottom row over there. Let's try one more. So I'm going to do angle MHK. And I'm just going to look at the top numbers here. So this is halfway between 120 and 130. So that's 125. And then on the other end, again, we're halfway between 30 and 40, which we said was 35. So if I'm finding the difference between 125 and 35, Well, 5 minus 5 is 0, 12 minus 3 is 9. So that would be a 90-degree angle. Alright, so today's big idea is the angle addition postulate. You might remember our segment addition postulate. We had A, B, and C, and maybe this was 12, and this was 19, and we said I could add AB plus BC to get the whole segment of AC. So I could take 12 plus 19 to get 31 for my whole segment. Well, same idea here. It's just we're going to use angles instead. So now I'm going to look at my angle XYW. I'm going to say angle XYW plus the other small part, angle WYZ, equals angle XYZ. Let me move this down a little bit. And then if I want to write that out, I could say 25 plus 32 is going to get my whole angle. So that would be 57 degrees. Or we could do the same idea. Over here I've got EDF. So angle EDF plus angle CDF equals my whole angle of EDC. So I can write out 82 plus 48 equals my whole angle of 130 degrees. So our big idea, again, we add the two smaller pieces to get the whole angle. So here I could take 21 plus 23 to get my whole angle. And that's going to be angle CDF. So that is 44 equals angle CDF. So angle CDF is 44 degrees. Now, just like our segment addition postulate, we wrote out segments where we had expressions like this. We put variables in it. So the first thing you need to look for whenever you see expressions like this is you've got to check, do I have a measure for the big angle? And in both of these, we do. So I've got angle ABT plus angle CBT equals angle ABC. So if I take my ABT plus CBT equals the whole angle there of ABC, and then I can fill in my known values. So I can say 5x minus 17 plus 3x plus 14 is going to equal, and what is my whole angle here? Well, the whole thing we were told was 125. So you've always got to be on the lookout for that whole angle there. And then we can combine our like terms of 8x minus 3 is 125. So let's see, that's 128. So 48 and 80 would be x is 16. I'm going to move this over a little bit. All right, now let's do the same thing for our second angle over here. So we've got the two parts, 3x plus 36 plus 9x minus 14. And what's my whole angle again? Do I have a whole angle? Did they give me a value? And they did. They gave me 106. So we can combine our like terms again. So I've got my x's, so 12x, and then this is plus 22, gets me 106, or 12x equals 84, so x would be 7. And then if I wanted to, I could ask you guys to plug that back in and find each angle, but I'm not going to. And we're going to come back to this idea of being very careful to look for that big angle measure, see if they give us that. We'll come back to that in just a minute. So another very important concept you need to know is the term bisected, and we looked at this earlier. So we just saw problems where they gave us a measure for the big angle. Here they're telling me it's bisected. And what does it mean to bisect? Well, that means to cut into two equal pieces, or cut it in half. So if this half is 37, well, the other piece must be equal to it, because it's cut into two equal pieces, it's cut in half. So if that's 37, then my other side must be 37. Or over here, if this is cut right down the middle, if that's 48, well, then my other side must be 48 as well. And that's, again, that means cut in half, that word bisected. So I'm going to pause here in just a minute. We're seeing more problems where I'm given these expressions. And earlier we looked for a big number up top. We said, did they tell me that whole angle measure? Or in the problem next to it, did they tell me what that big angle was? And in this case, they did. They said it was 106. But what if I am given a problem like this, where they don't tell me what the big angle is? Well, here they tell me it's bisected, or cut into equal pieces. And if you remember, we had problems where it was like 48 and 48. Well, what do I know about the numbers 48 and 48? Well, they're equal to each other. So 48 is equal to 48. It's bisected. this angle is. So, same idea here. If you ever see the word bisected, should have some alarm bells going off in your head. Bisected means to set these two pieces equal to each other, because like we saw before, 37 was equal to 37, and 48 was equal to 48. Same idea down here. If this is bisected, then 1/2 x plus 24 equals 3x minus 46. So I can solve for x from here. So let's see, this is, if I subtract 1/2 x, then I've got 24 equals 2.5x, not plus, minus 46. And then I can add 46 to both sides. And 2.5x equals 70. And we can divide 70 by 2.5 to find our final answer. So same idea on the right. We know this is bisected. That's our key word, bisected. Cut into two equal pieces. So we'll set our two parts equal to each other. And I'll say, I see a positive 3x. I'll subtract 3x from both sides. So now I've got 36 equals 6x minus 14. I can add 14 to both sides. I should probably do that in red again. And then I've got 50 equals 6 times x, where x is 8 2/3. Or if you want a decimal, 8.6 repeating. And then over here we've got x equals 28. So that's all we need for today's lesson. Let me know what questions you guys have, and I will see you